Right, so here's our little problem here. We got a rectangular reinforced concrete beam. It's 14 inches wide. It has an effective depth of 16 inches. It has three number 9 bars reinforcing it. F prime C is 4 KSI, Fy 60 KSI. And our problem here is let's find the nominal moment capacity. So again, this is sort of your base level evaluation type problem. You got a beam. Let's find out how much nominal moment capacity it can hold. All right. So basically, it's your first type of problem. All right. Anyway, I usually like to say there's like 3 steps in this type of problem. First step. Let's find what the tension force is. Okay? So how big could the tension force get with 3 number 9s? Well, it's a tension force, right? Back in strength of materials, you said stress is equal to force divided by area. But now, you're talking about force. So force is equal to stress times area. You'd have to look in the tables to find out what the area of steel is for 3 number 9s. You look in a table, you find out that the area of 1 number 9 is 1 square inch. So 3 number 9s has an area of 3 square inches. So tension, force, is equal to stress times area. What stress level do you think I'm interested in? How about the yield stress? So force is equal to stress times area or area times stress. When I'm dealing with concrete, it looks like that. Tension force is equal to AS, area of steel, times Fy. My area of steel in this problem is 3 square inches. My Fy, yield strength is 60 KSI. My tension force is going to be equal to 180 kilograms. All right? Questions on that? Step 2. Well, the tension force is on the tension side, but there's another force on the compression side. So we know they have to be equal to one another. T has to be equal to C, and in this problem, that means it's equal to 180 kips. Well, what is the compression force made up of? Well, I already told you. It's made up of a stress block, right? The stress block is 0.85 F prime C. That's how big the stress gets. What's the area of the stress block? Well, the area was the depth of the stress block A times how wide the beam is. That stress block stretches across the whole width of the beam. So again, stress times area. Stress times area. Okay? 180 kips. My concrete's compression strength's 4 KSI. I don't know what A is, but I do know the width of the beam, 14 inches. So I can rearrange this and solve for A. And what would that be? A comes out to be what? 3.8. Say that again? 3.8. 3.8? 3.8 exactly?
0.7815.
Okay. 3.781. Let's call it 3.78. All right? So you know the depth of your stress plot. My third step is just using that formula we had up there before. Mn is equal to T times the quantity of D minus A over 2. In this case, T is 180 kips. D, 16 inches. A was 3.78. I'm going to divide that by 2. Now, if I just leave it like that, I'm going to come out in units of inch kips, which is fine. I mean, we can have inch kips. So somebody tell me what that is. Yell it out again, please. 2539.8. We'll say 2540. And again, that'd be inch kips. Okay. Now, if you divide that by 12, you can get it into foot kips. So divide it by 12. 11.65. Okay. So that's 211 point, we'll say 7 foot kips. So there you go. You got your first problem, evaluation type problem down. You know, we took a rectangular reinforced concrete beam and we went through basically 3 steps. And utilizing that last formula we had from last time around, we came up with a nominal moment capacity. Now that's not design. If I wanted to go ahead and do design, what would I have to do? Well, not factor your load. You'd have to multiply Mn by a resistance factor. Okay? So, anyway, the 3 steps to get Mn are as we've outlined right here. Okay? Questions?
Do you want it in a certain inch or foot per kip?
Well, this is a moment, so it's inch kips or foot kips or inch pounds or foot pounds, you know.
You don't care which?
I would say feet, you know, using feet's probably more common than inches. But, you know, it's up to you. I mean, as long as you're comparing it to the right thing, it doesn't, you know, as long as you're straight on the units you're using, I don't care what units you use. All right, other questions? Okay, design, if this Mn was 211.7 foot kips, if I did ask for design moment capacity, only thing you got to remember is for bending, and this is going to be a lot like steel was, the resistance factor is 0.9. So for this, if I was interested in calculating phi Mn, the design capacity, it'd be 0.9 times 211.7 foot kips. So that would be my design capacity when I calculate that out. So what would that come out to be? All right. So you're, you know, again, always be straight with what the homework problem or the test problem is actually asking for you. You know, some of these homework problems, when I say, just calculate Mn. They're just, you know, trying to get you used to it. Well, that's fine. Calculate Mn. Most of our problems, especially as we get deeper into this, will be saying, you know, we're interested in design capacity. Okay?